This topic is about using trigonometric identities to solve equations. We will start by deriving the trigonometric identities from the unit circle. So because this is the unit circle, the radius is equal to 1 in this case. And if there's a point P on the circumference of the circles on the first quadrant, then it has x coordinate x. So that means the base will be equal to x and the height will be equal to y. Then sine theta is equal to opposite over hypotenuse, which is equal to y over 1. Y over 1, which is equal to y. Cos theta will be equal to adjacent over hypotenuse, which is x over 1, which is equal to x. Okay, tan theta is equal to opposite over adjacent, which is y over x. But y is just sine theta and x is just cos theta. So we get the first trigonometric identity. So tan theta is equal to sine theta over cos theta. Okay. Now using Pythagoras theorem, because this is a right angle triangle, we know that a squared plus b squared is equal to c squared, which means x squared plus y squared is equal to 1 squared. But remember, x is just sine theta, so it's sine theta all squared. Remember, when it's sine theta all squared, we write sine squared theta plus cos theta all squared, which means it's cos squared theta. Oops. I've just realized I've swapped the y's and the x over, but it doesn't matter, is equal to 1. And that is our next, the second identity that you need to know. So sine squared theta plus cos squared theta is equal to 1. I just feel like I shouldn't have written that way because it's not the right one. So x squared would be cos squared theta. Yep, and y squared would be sine squared theta, which is equal to 1 squared, which is 1. But obviously, addition is commutative, so it's the same thing as writing sine squared theta plus cos squared theta is equal to 1. So that is our second identity. So because it's an identity, it's identically equal to 1. And this one is also identically equal to tan theta is equal to sine theta over cos theta. Now, there are equivalent versions of the formula. So this can be rewritten as if tan theta is equal to sine theta over cos theta, then 1 over tan theta will be equal to 1 over sine theta over cos theta, which means the denominator, the second fraction flips over. So it's the same thing as cos theta over sine theta. So that's a different version of the same formula. If I look at this one, if I rearrange it and take the cos squared theta to the right hand side, then I get sine squared theta is equal to 1 minus cos squared theta. So that's another version of the same identity. But I could also take the sine squared over to the other side, so I get cos squared theta is equal to 1 minus sine squared theta. So that is again a different version of the same identity. So just be comfortable using whichever version you need to, obviously when you're proving. Okay, the other thing to be wary of, note, if I change the input, so if I change the input of the trig function, then all these inputs need to change at the same time. So here, if I change this input, then this input needs to change. So that means if I have tan, so let me just write that, all input of trigonometric functions need to be the same. So i.e., if it's tan 2x, because the input is 2x for the tan function, then it's the same thing as sine 2x over cos 2x. So if you think about it, the theta has been replaced by 2x, so the theta here has to be replaced by 2x, and the theta there has to be replaced by 2x. Okay, so that is correct. So that works out. In a similar way, if I have sine, in the second identity, if I have sine squared 5y, then it has to be plus cos squared 5y. Same input would be equal to 1. So again, because the theta has changed to 5y, the theta here has to change to 5y as well. So that works out. So not, for example, not these ones. So if I have sine 3x over cos 3x, what people tend to do is just think, okay, I can cross that out and that must be equal to tan x. Tan x. But that is incorrect. Okay, so if I use red, then that is wrong. So this is not correct here. If I do another example, what people tend to think is sine squared, if I have 2x plus cos squared 2x, they think because this has doubled, then obviously the 1 has to double to 2. So that is obviously all incorrect. It's still equal to 1. So that's incorrect. So just remember, if you change the input, you have to change the input everywhere. Okay, so let's go through some examples of using these two new trig identities to solve equations. Oh, I've written it here, so it's fine. Okay, so first one is solve 3 sine 2x minus 4 cos 2x equal to 0, where minus 80 is less than or equal to x, which is less than 180, so it's not including 180. So let's write out our trig equation that we start off with. Now we can see there's no squares involved, it's just sine x and cos 2x. It's going to be the first identity that we're going to use. So if I take the minus 4 cos 2x to the other side, I end up getting 4 cos 2x. Now if I divide by cos 2x, I end up getting 3 sine 2x over cos 2x is equal to 4. Now I know using sine 2x over cos 2x is equal to tan 2x. Remember, we have to change the input and the same consistently. Then I get 3 tan 2x is equal to 4. Now I need to divide by 3, so I get tan 2x is equal to 4 over 3. Now I let u, so that I get let u be equal to, because I've got in a function 2x, let u be equal to 2x, then tan u is equal to 4 over 3. Now we need to adjust our range now, because minus 180 is less than or equal to x, which is less than 180. If I double it, 2x, because obviously my input is 2x, then I get is between 360 and minus 360, only including minus 360. So u goes from minus 360 to plus 360, with not including 360. So if I do u and I do inverse tan of 2x, then I get the u values of, the first u value I get is 53.1301 degrees. Okay, now because it's a tan graph, remember tan graph repeats itself every 180. Something like that. So I've got 53.13, which is somewhere here. If I need to find the next one, I need to add 180. If I need to find the one previous to, I need to minus 180 all the way up to minus 180 to see how many I can get within the range. So if I add 180, I get 233.1301 degrees. Okay, and the next one would be over 360, so I don't want the next one. If I add 180 to this value, I get a number more than 360. So I need to go back to 53.1301, and then take away 180, which gives me minus 126.8699. And then from this value, which I've got now, so I've got this one, I've got this one, I've got this one. I need to take away 180 again. So it means I get minus 306.8699. The next one will be less than minus 360, so I don't need to do any more. So that was u. So u, which is equal to 2x. So if I need to find x, I just need to divide by 2. So if I divide everything by 2 and then round it to 2 decimal places, I get 53.1301 divided by 2 gives me 26.57 degrees. 233.1301 divided by 2 is 116.57 degrees. Minus 126.8699 degrees divided by 2 gives me minus 63.43 degrees. And the last one, minus 306.8699 degrees divided by 2 is minus 153.43 degrees. And these are all values of x, so these are 4 solutions to my original equation. Okay, next example. 3 sine x minus tan x equal to 0 between minus 180 and 180, not including 180. So 3 sine x minus tan x equals 0 means I've got 3 sine x, so minus tan x is just sine x over cos x, which is equal to 0, using tan x is equal to sine x over cos x. Okay, if I multiply through by cos x, then I get 3 sine x times cos x, which is 3 sine x cos x, minus sine x over cos x times cos x just gives me minus sine x is equal to 0. Now, the common mistake people do here is they divide by sine x, which gets rid of some of the solutions. So remember, don't divide by a common factor unless it's constant, or else you're going to lose solutions. So what you should do instead is factorize the sine x out. So sine x times 3 cos x minus 1 equals 0. Now you have two situations. Either sine x equals 0 or 3 cos x minus 1 equals 0. So x is equal to inverse sine of 0, which is 0 degrees. Now if you think about the sine graph, so the sine graph, remember, every 360, it repeats itself. We're only looking at it from minus 180 to positive 180. So 0 is one of the solutions. We're not including 180, so 180 is not a solution, but minus 180 is, because it's within the range. So 0 degrees and minus 180 degrees. Okay, for this one, for the second set of solutions, you get cos x is equal to a third. So x will be equal to inverse cos of a third. So from your calculator, you get the value 70.53 degrees when you do inverse cos of a third. So this is y is equal to sine x. Y is equal to cos x. You're going from minus 180 to 180. So you've got 70.53 here. So the other value will be, so if this is 70.53, then the other value will be obviously negative. Sorry, let me just delete the negative here. Will be negative 70.3 because it's reflected along the y-axis. So negative 70.53 degrees. Let me make that point more clear. Okay, let me just write y equals tan x here. Okay. Solve for 0 degrees to 360 degrees, not including 360. The equation 5 sine squared x is equal to 1 plus cos x, giving your answer to 1 decimal place. Now, because it's got a sine squared involved, I know I'm going to use the second identity. So 5 sine squared x is equal to 1 plus cos x. So I need to use the right version. So using sine squared x plus cos squared x is equal to 1. 5 times sine squared will become 5 times 1 minus cos squared x is equal to 1 plus cos x. I expand the bracket, I get 5 minus 5 cos squared x is equal to 1 plus cos x. If I take everything to the left-hand side, I get, sorry, right-hand side, let's move everything to the right-hand side so we get positive cos squared. I get 5 cos squared x plus cos x. 1 take away 5 is minus 4 equals 0. If I'm factorizing this, I get 5 cos x in one bracket, cos x in the other. I want a positive cos x, so I need to put a plus 1 here and a minus 4 here. So I've got two situations, either 5 cos x minus 4 equals 0, or, I've got to highlight this one, or cos x plus 1 equals 0. So let's do the easier one first. So cos x is equal to negative 1. X is equal to inverse cos of negative 1, which is equal to 180 degrees. Okay, so if you think of the cos graph, only from 0 to 360, so y is equal to cos x, and only one point where is equal to minus 1, which is at 180 degrees. So that's the only solution for that equation. For this one, for the first one, we've got cos x. For rearrange, then we get cos x is equal to 4 over 5. So x must be equal to inverse cos of 4 over 5. If you put that into your calculator, the first value, because we're rounding to one decimal place, you get 36.9 degrees. Now 36.9 is somewhere here. So I need to find this point, which is going to be 360 take away 36.9. 360 take away 36.9 is 323.1 degrees. Show that 4 sine squared minus 3 cos squared x is equal to 2 can be written as 7 sine squared x is equal to 5. So because we're eliminating cos squared from the original equation, so using the first identity, sine squared x plus cos squared x is equal to 1. And we're eliminating sine squared, so that means change sine squared to 4 times 1 minus cos squared x minus 3 cos squared x is equal to 2. If we expand that, I get 4 minus 4 cos squared x minus 3 cos squared x is equal to 2, which means 4 minus 7 cos squared x is equal to 2. If we take the 7 cos squared x to the other side, 7. Oh, we did the wrong thing. Now, how did I know I made a mistake? Because we left with cos squared x. So obviously we wanted, I forgot, we're aiming for sine squared x. So we keep the sine squared x in the equation and we change the cos squared, yeah? So we've got, using sine squared x plus cos squared is equal to 1. I've got 4 sine squared x remains as 4 sine squared x minus 3 lots of, I need to change the cos squared x to 1 minus sine squared x is equal to 2. So when I expand this, I get 4 sine squared x minus 3. Minus 3 times minus sine squared x gives me plus 3 sine squared x is equal to 2. 4 sine squared x plus 3 sine squared x is 7 sine squared x. And then if you move the minus 3 to the opposite side, you get 2 plus 3, which is 5. So that works out. So be very aware of what you're aiming for, yeah? So I made a mistake there. You always need to keep an eye on what you're aiming for and then eliminate what you don't want. Hence, solve for 0 to 360 the equation 4 sine squared x minus 3 cos squared x is equal to 2. Now, because it says hence, it means I need to immediately change 4 sine squared x minus 3 cos squared x equal to 2 to what I've proven. So that's the same thing as, so 4 sine squared x minus 3 cos squared 3 cos squared x is equal to 2 is the same thing, because we've already proven this, as solving 7 sine squared x is equal to 5. Which means sine squared x is equal to 5 over 7. Which means sine x is equal to plus or minus root of 5 over 7. So there's two sets of solutions. Okay, so let's go. So either sine x is equal to root of 5 over 7, or sine x is equal to negative root of 5 over 7. So the first one, x will be inverse sine of root 5 over 7. And the value you get from your calculator to one decimal place is 57.7 degrees. Now, if you think of the sine graph, from 0 to 360, it looks like this. So if we know the first value is 57.7, then to get this value, I need to do 180 take away 57.7. 180 take away 57.7 is 122.3 degrees. Those are the only values between 0 and 180. If I do sine x is equal to inverse sine of, sine x is equal to negative root 5 over 7, then x will be equal to inverse sine of negative root 5 over 7, which means x is equal to the first value you get. So you get the value negative 57.7 degrees. Okay, now that's not within our range, so I can cross it out. But if I draw my sine graph out, so this is y is equal to sine x, which is here. Oops, sorry. Negative 57.7 is here. So what I need to do is I want to find this one and that one. So the first one's going to be 180 plus 57.7, which is 237.7 degrees. So that's the first value. To find the second value, which is here, I need to do 360 take away 57.7, which is 302.3 degrees. So that would be it. So remember, if it's outside the range, cross it out. If you don't cross it out, you lose a mark in an exam. So make sure you cross out any that are not within the range. Show that the equation 2 sine squared x plus 5 cos squared x is equal to 1 can be written as 3 sine squared. So we want everything with sine remaining. So I need to change cos. So A is, so always keep an eye on what you're aiming for. So using sine squared x plus cos squared x is equal to 1. So I need to eliminate the cos squared. So the 2 sine squared x remains the same. The cos squared changes to 1 minus sine squared x is equal to 1. So I end up getting 2 sine squared x plus 5 minus 5 sine squared x, when I expand the bracket, is equal to 1. So I get negative 3 sine squared x plus 5 is equal to 1. If I take the negative 3 squared over to the other side, I get 3 sine squared x on the other side. And 5 take away 1 gives me 4. So that means I get 3 sine squared x is equal to 4, which is what I wanted. B. Using your result in part A to explain why the equation 2 sine squared x plus 5 cos squared 1 is equal to 1 has no solution. So because we're using a result from the beginning, if I'm trying to solve 2 sine squared x plus 5 cos squared x is equal to 1, it is the same thing as solving 3 sine squared x is equal to 4. Which means sine squared x is equal to 4 over 3, which means sine x is equal to plus or minus root 4 over 3. But what we do know is root of 4 over 3 is greater than 1, and negative root 4 over 3 is less than minus 1. No solution, because sine x goes from positive 1 to minus 1. So it's not defined for any number. Because the range of the sine x, it goes from 1 to minus 1. These are numbers greater than 1 and less than minus 1. Okay, solve the following equation in the interval given. Okay, 4 sine theta plus 45 is equal to 5 cos theta plus 45 from 0 to 50. 450. So 4 sine theta plus 45 degrees is equal to 5 cos theta plus 45 degrees. Just not going to write the degrees at the moment because that's not important. Okay, so I know I've got sine and cos involved, no squares involved, so it's going to be the first identity. So if I divide by cos theta plus 45 both sides, I get 4 sine theta plus 45 over cos theta plus 45 is equal to 5. And using tan theta is equal to sine theta over cos theta, the input has changed consistently for sine and cos. So it's going to be the same thing as 4 tan of theta plus 45 is equal to 5. Which means tan theta plus 45 is equal to 5 over 4. So we need to let u be equal to theta plus 45. Then we have tan of u is equal to 5 over 4. So remember, theta, we need to just arrange. Theta is between 0 and 450, which means theta plus 45 will be equal between 495, because we have to add 45 to 450. We have to add 45 to 0. Between 45 and 495. So u goes from 495 to 45. So to find u, I need to do inverse tan of 5 over 4. So u is equal to, when you do inverse tan of 5 over 4, the first value you get is 51.3 degrees. Now because it's a tan graph, remember, so the tan graph goes, remember, it repeats itself every 180. So when you, y is equal to tan x. So when you got one value, if you want to find the next one, all you do is add 180 and subtract 180. So when we add 180, if we get the next one, we get 231.3 degrees. And the next one would be 411.3 degrees. If we keep adding 180, it goes beyond the range. It goes over 495. So we can't do anything more. And remember, this is the same thing as theta plus 45. So if I want to find theta, all I need to do is subtract 45. So theta will be equal to 51.3 take away 45, which is 6.3 degrees. 231.3 degrees take away 45 is 186.3 degrees. And 411.3 degrees take away 45 is 366.3 degrees. So there's 3 values. Okay, let's try B now. So B is 2 sine 2x. 2 sine 2x minus 7 cos 2x is equal to 0. The range going from 0 to 180. Okay, so I know it's sine 2x and cos 2x. So it's going to be, I need to eliminate to make it tan. So I've got 2 sine 2x. 2 sine 2x is equal to 7 cos 2x. If I divide by cos 2x, I get 2 sine 2x over cos 2x is equal to 7, which means 2 tan 2x is equal to 7. Using the first identity, which is tan x is equal to sine x over cos x, the input has changed consistently, so that works. Okay, which means tan 2x is equal to 7 over 2. Let u be equal to 2x. Then we have tan u is equal to 7 over 2. And our range is 0 is less than equal to x, which is less than equal to 180. So 2x will be between 0 and 360. So u goes between 0 and 360. Okay, so if I do, to find u, I need to do inverse tan of 7 over 2. So u, which is equal to 2x, is equal to, the first value I get is 74.05 degrees. 74.05 degrees. Remember, because it's tan graph, I'm not going to draw it again, but remember, just like the first one here, tan graph, it repeats every 180. So I need to add 180 to get the next one, which is 124.05 degrees. So this is 2x, remember. So all I need to do is divide by 2 to find x. So x will be equal to, when I divide by 2, if I round it to, let's just do one decimal place, I get 37.0 degrees, and 124.05 divided by 2 is, oh sorry, I made a mistake. When I do 200, so 74 degrees plus 180 is 224.05. No, that's not right again. So 74.05 plus 180 is 254.05. Make sure I use my calculator properly. And then when I divide by 2, I get 254.05 divided by 2 is 127.0 degrees. So there's two solutions. That would be it. Next one is C. So let's do C here. I've got root 3 sine of x minus 60 plus cos of x minus 60 is equal to 0. And I'm going from minus 180 to 180. So if I divide by cos 2x, I get root 3 sine of x minus 60 degrees divided by cos of x minus 60 degrees. Cos of x minus 60 degrees divided by cos of x minus 60 degrees gives me plus 1 is equal to 0. Okay, what I end up getting is sine x minus 60 over cos x minus 60 is tan x minus 60. So I get root 3 tan of x minus 60 plus 1 is equal to 0, using tan x is equal to sine x over cos x. So if I rearrange now, that means I get tan x minus 60 is equal to positive 1 becomes negative 1, and then I need to divide by root 3. Okay, the next thing I need to do is let u be equal to x minus 60 degrees. Then I have tan of u is equal to negative 1 over root 3. And to adjust my range, I've got my range at the moment of x being between minus 180 and 180. So x minus 60 will be in between. I subtract 60 from 180, I get 120. If I subtract 60 from this one, I get minus 240 degrees. So u goes from 120 to negative 240. So if tan u is equal to negative 1 over root 3, so u will be equal to inverse tan of negative 1 over root 3. So u would be equal to, the first value I get is negative 30 degrees, which is okay within the range. I need to subtract and add 180 until I get the next one. If I add 180, I get 150, which is not in the range. So I need to subtract 180. I get minus 210 degrees, which is in the range. And if I subtract again, it won't be in the range, because minus 210 minus 180 is definitely less than minus 240. Okay, so that is u, which was x minus 60 degrees. So if I want to find the next one, so if I want to find x, all I need to do is add 60 degrees. So x will be equal to minus 30 plus 60 is 30 degrees. And minus 210 plus 60 is minus 150 degrees. So that would be it. Given that 4 sine x is equal to 3 cos x, write down the value of tan x. So 4 sine x is equal to 3 cos x. So if I divide by cos x, I get 4 sine x over cos x is equal to 3. Using sine x over cos x is equal to tan x, I get 4 sine x over cos x is the same thing as 4 tan x is equal to 3, which implies tan x is equal to 3/4. Part B, solve for 0 to 360, 4 sine 2 theta is equal to 3 cos 2 theta, giving you answer to 1 decimal place. So we're solving 4 sine 2 theta is equal to 3 cos 2 theta, which looks very similar to the thing that I proved first. So I know 4 sine 3x is equal to 3 cos x gives me tan x is equal to 3/4. So this is the same thing as, because the tan x has, sorry, the input has changed to 2 theta, it will be the same thing as tan of 2 theta is equal to 3/4. Okay, so then I let u be equal to 2 theta, then I've got tan of u is equal to 3/4. I need to adjust the range. So theta goes from 0 to 360. So 2 theta will go from 0 to 720, which means u will go from 720, from 0 to 720. I'll find out u, which is 2 theta, I need to do inverse tan of 3/4. When I do inverse tan of 3/4, the first value I get, so 2 theta, which is u, will be equal to 36 point. Now, because I want the answers to 1 decimal place, I'm going to round at this point to 2 decimal place. So I get 36.87. Now, don't forget the tan graph repeats itself every 180. So you have to add 180. So the first next value will be 216.87 degrees. Remember, the range is between 0 and 720, so keep adding 180 until you can't, it's outside the range. So when you add 180 to 216.87, you get 396.87 degrees. If you add another 180, you get 576.87. If you add 180 again, it's going to go outside the range, so that is it. You've got 4 values. Now, that's 2 theta. I need to find out my solution for theta. Solve for theta, so I need to divide by 2. So theta will be equal to 36.87 divided by 2, and round it to 1 decimal place is 18.4 degrees. 216.87 divided by 2, 108.4 degrees. 396.87 degrees divided by 2 is 198.4 degrees. The last one, 576.87 divided by 2 is 288.4 degrees. So that I get 4 solutions. Next question, find all the solutions into interval 0 to 360 to the equation 8 sine squared x plus 6 cos squared x minus 9 equals 0, giving each solution to 1 decimal place. So I've got 8 sine squared x plus 6 cos x minus 9 equals 0, which means I need to get rid of either sine squared or the cos. Obviously, there's an identity involving sine squared, so I'm going to eliminate sine squared. So using sine squared x plus cos squared x is equal to 1, I get 8 times, if I make sine squared the subject of the identity, I get 1 minus cos squared x plus 6 cos x minus 9 equals 0. If I expand the bracket, I get 8 minus 8 cos squared x plus 6 cos x minus 9 equals 0. Okay, 8 minus 9, I get minus 8 cos squared x plus 6 cos x. 8 minus 9 is minus 1 equals 0. If I change the sign consistently by multiplying by minus 1, I get 8 cos squared x minus 6 cos x plus 1 equals 0. Now I need to factorize it. So by trial and error in my head, I get 4 cos x in one bracket and 2 cos x in the other. I need to put minus 1 and a minus 1 because then I get minus 4x minus 2 cos x, which gives me minus 6 cos x. Which means I either get 4 cos x minus 1 equals 0 or 2 cos x minus 1 equals 0. And if I rearrange the first one, I get cos x is equal to 1/4, which means x is equal to inverse cos of 1/4. which means x is equal to 75.5 degrees. And if you think about the cos graph, it looks like so, from 0 to 360. So if the first value is 75.5 degrees, the second value will be 360 take away 75.5, which gives me 284.5 degrees. So those are my two solutions between 0 and 360. If I do the same thing for this one, then cos x will be equal to a half, which means x will be equal to inverse cos of a half, which gives us 60 degrees in our calculator. Again, if 60 degrees is a solution, so if 60 degrees is a solution here, which is 60 degrees, then the next one, which is here, would be 360 take away 60 degrees, which is 300 degrees. So this was y is equal to cos x. Next equation, question. Show the equation 2 cos squared x plus cos x minus 6 is equal to 0 has no solution. So 2 cos squared x plus cos x minus 6 equals 0. It can be factorized, so let's factorize it. I get 2 cos x in one bracket, cos x in the other. I have to have a negative 3 and a 2. I need the negative 3 here and the plus 2 here, because then I get negative 3 cos x plus 4 cos x, which is 1 cos x. So either I have 2 cos x minus 3 equals 0, or I've got cos x plus 2 is equal to 0. If I rearrange this, I get cos x is equal to 3 over 2, and cos x is equal to negative 2. Both of them have no solution. This is greater than 1. This is less than minus 1. No solution, as the range of cos x is between minus 1 and 1. Therefore, outside the range of cos x. Okay, the last question I'm going to go through, tan squared x minus 2 tan x minus 4 equals 0. Show that tan x is equal to p plus or minus root q, where p and q are numbers to be found. Okay, so in this case, I've got, remember, the coefficient in front of tan squared x, a is equal to 1, b, so this is, part a. b would be equal to negative 2, so the coefficient of tan x, and c is equal to negative 4. So my subject of the formula, normally it's x is equal to minus b plus or minus so on for the quadratic formula, but here it will be tan x, because tan x has replaced x in this quadratic equation. So tan x will be equal to minus b plus or minus root of b squared minus 4ac all over 2a, which means it's going to be minus 2 plus or minus 2 squared minus 4 times 1 times minus 4 all over 2 times 1, which means you get 2 at the top for the first term, 2 at the bottom there. Minus 2 squared is 4 plus 16 gives me plus 20, root 20, which is the same thing as 2 plus or minus root 20 can be simplified as root 4 times root 5, which is 2 root 5 all over 2. There's a common factor of 2 everywhere, so it's the same thing as 1 plus or minus 1 root 5 over 1, which is just 1 plus or minus root 5. So therefore, tan x is equal to 1 plus or minus root 5. So in this case, your p is equal to 1 and your q is equal to 5. Oops, so that was A done. Let's do B now. Hence, solve the equation tan squared x minus 2 tan x minus 4 is equal to 0 in the interval 0 to 540. So you have two situations, one where tan x is equal to 1 plus root 5, and one where tan x is equal to 1 minus root 5. So x will be equal to inverse tan of 1 plus root 5. So in your calculator, the first value you get is 72.8 degrees. Now you keep adding 180 until you get the next one, until you go outside the range. So 72.8 plus 180 is 252. 0.8 degrees. And the next one would be, if you add 180, you get 432.8 degrees. And that is it, because the next one would be over 540. For the second set of solutions, you can do inverse tan of 1 minus root 5, which means x is equal to, the first value you get from your calculator is minus 51.0 degrees. Now we know that's outside our range, so I straight away cancel it out. So cross it out because we don't want it written down in our solution. So we need to add 180 to minus 51.0 to get the first value, which is 129.0 degrees, which is in our range. Add 180 again, so you get 309.0 degrees. If you add 180 again, you get 489.0 degrees. The last one is going to be greater than 540. So you don't have to worry about that one because it's outside the range.